let's talk about the ovens.
Okay.
Ovens are a big deal. The airflow, air movement in ovens is critical in many of the processes, powder especially.
Mm-hmm.
That airflow and air movement around powder particles in a convection oven is super critical. So,
Yeah.
talk to us about your capabilities with ovens.
Yeah. So you're right on ovens. I mean, we make them for wet cure, Dryoff, powder cure, preheat type instances sometimes. But like you was talking about the airflows and the things like that, and what we really like to concentrate on is the part again. It's sort of, in finishing, it always starts with the part. What are you coating? What are you trying to do? How an oven? How heavy is it? What's it made out of? How big is it? And is it a solid area or is it open and racking or whatever? Because those things all play an impact on the oven design. Now, like we talked about catalog equipment, we have ovens that are cataloged, right? They're built a certain way, and they're built to handle so much part load and have so much airflow. But again, going back to that engineered side, if I know what we're coating, or RTT knows the part, we might use a smaller fan because the part's really large and taking up a lot of oven volume. Because we build ours normally standard with 6 air changes in an oven for a powder cure in a batch oven. We want to get that ramp up time back up quickly between batches.
Right.
We typically run a little larger burner because of that, which the burner will dial back once it's at temperature, but we want to recover fast in a batch oven.
Correct.
So we're really proud of our ovens. We feel like they're a really, really good product for us. We have a lot of longevity out of those. We've done a lot of work in the control side of our ovens to give a lot of ability with our end users to see what's happening. We have an app that goes on your phone that can be tied into the oven, and at any time you can see what's happening with the oven. We can send notifications of temperature variations, of say, hey, we have a fault situation. Hey, the doors have been open for X amount of time. What's going on? Because in an oven, if the doors are open, it's not making you product. So it gives the ability for maintenance personnel, shop supervisors, production lines, even the CEO or president of the company has availability to see what's happening with his curing oven.
Yeah.
And we've done a lot of work in the troubleshooting of it. We're really proud of the controls around our ovens, and we feel they're best in class. And because of that, they offer our end users better uptime, because most guys aren't experts in finishing equipment. We see it all the time in the products that we make, and even maintenance personnel for customers they may know, but they're not perfectly trained on what happens in a finishing line. And when product goes down for some reason, or maintenance needs to be done and wasn't done, you have some issues sometimes. And with the controls, we've gave the ability for an inexperienced person to go to the touchscreen, and it walks them through and asks them questions. What's happening? And depending on how they're answering, it kind of directs them to the solution. So what we've seen is paint line supervisors are able to get ovens back online just because of something that happened that can be reset.
They have a roadmap.
They have a roadmap to go. They're not calling a service tech or calling a manufacturer, waiting on our customer service team to try to troubleshoot it with them. They're able to get up and running really quickly. So, we're pretty proud of the controls on those things. And ovens are a big part of our product line, and really what we move as far as products.
I liked what you said about the average burner size skewing a little bigger. That's a big deal in the powder side, the recovery time. Powder ovens, and there's a lot of automated ovens that run all day long. You have 2 vestibules, 1 entry, 1 exit.
Right.
Not a whole lot you can do. You set it up and you do your thing.
That's right.
It's the amount of time that part is in that oven is great. Dictates how slow the line speed's going to have to be, or how hot the speed, or how
Exactly.
the oven needs to be.
Well, in a batch situation, especially, so you have a lot of job shops. And what are they going to try to do? They're going to try to coat whatever they can.
Yeah.
And they start putting bigger things in there than really what we were wanting to, or something heavier, and they push the limits of that oven. And it honestly gives our customer base a little flexibility to kind of do that, to where they can still get their batches in, and they recover a little slower, ramp up the temperature a little slower, but they do have enough BTU to maybe coat something that we didn't really design for that,
Yeah. Well, see, there's a lot of loss of that. There's a lot of loss of the heat.
Oh, sure.
Because if you've got an oven that A, does not hold its temperature very well, or B, can't ramp back up very well, for those of you new to powder coating or liquid painting or things like that, and you're watching this and learning about some of the oven technology, powder coating cures at, let's just say, around 400 degrees, 392 degrees for 12 minutes, 15 minutes. And those are all rough and based on the vendor and their bailiwicks and their black magic.
Right.
But let's just take that basic. There are devices that you can use that you can measure that temperature. Data pack, and there's others. But you can actually put your probes on those parts and watch them. And I've seen where, let me step back. The biggest problem is that somebody who's running a batch operation, that oven is being used for multiple things. So their booth is usually not far from the oven. The oven and the booth and the oven are not far away from the wash bay where they're pre-treating. So they pre-treat with whatever their process is, and when they bring it over to they can't go in the booth wet, so they have to put it in the oven for a dry-off, which leads me to something else. If they have horrible ground in the booth, they now have to really get that part hot.
Right.
Because they're not relying on a good powder gun and good ground, and they're just hot flocking every part that comes in, trying to melt the powder on contact. That's another thing that will go down. But once the oven becomes a bottleneck in their process, because that oven, they've got to do 2 cycles with it. One, to dry it off after the pre-treatment, and then the second, so they've opened up the doors, they've lost all kinds of heat, and then they put the part in to dry it off, so you're getting rid of the moisture, you're drying off that metal. Then they pull it out, and they go into the powder booth. They've left the door open for a minute, they get it shut, they go back over to the powder booth, they start to powder coat, and then they got to come back over and open up the door again fairly quickly to get back in there to cure. Then they're taking it out again. So all day long that door is opening and closing. With the data pack, I've seen ovens before that have dropped less than half in like literally the couple minutes that it takes to open up your oven door and get your parts rolled in or out, and then to get the door shut back. I've seen part temperature or oven temperatures drop more than half. And if you don't have great circulation, great airflow within that oven, and the burner to keep that heat focus in that oven, you could count on a lot more time that your part needs to be in your oven than the average system that's developed, because you got to get up to cure temps.
That's right.
Everything with powder cure is time and temp.
Right.
If the temperature is hotter, you can have a less cycle of time.
Your part temperature.
The temperature is a little lower. It just keeps going out.
Right.
And so the burner, airflow, and the oven's ability to retain temperature are all three huge deals.
They are, yeah. And you gave me a great segue to something that I didn't discuss earlier. In our controls, you talk about reading the data of what's happening inside the oven and recording that and getting that part temperature, right? Because, like you said, you can elevate the air temperature to get faster batches, because if you can say the metal temp needs to be 320 and it's got to be there for 20 minutes, let's say. Well, if I can run at a hotter temperature, my metal temp gets the temperature faster, right? And people try to speed their batches up that way. And in a lot of job shop, especially batch applications, right, they don't always do the same parts. You know, a process oven on a conveyor line is set up pretty much for the same parts, right? And we don't need as much airflow a lot of times. We can dial in the burners a little better. Ovens are usually bigger, but they don't, you know what I mean? They're not opening the door. They're not losing heat. Once they come to temp, they kind of run at temperature all day. They shut them down. And a batch application doesn't work that way. So we've implemented a new control that we call a smart batch. And what it is it hooks into our control system, and you have probes. And you can take those probes and put them on your part. And then we have options. We don't start the batch time until the part temperature gets to 320, let's say.
Where do the probes come from? Are they coming from outside the unit?
So they run from our controller.
With those cables.
That's right. High temp cables, and you can run them clamp style, or you can run magnets. If you don't have a place that you can hide the probe, let's say, then you can just put, let's say that it's a piece of C-channel on your part, and that's the heaviest piece of metal.
Oh, yeah.
Right? And you can take just a piece of section of C-channel and set it with your batch and put the clamp on that, right?
Yeah.
If you don't want to disturb your coating. And then that batch time, let's say that we need 320 for 20 minutes. Once we see that part has got the 320, we start the batch time.
I used Unistrut a lot. You know,
Right.
It was a simple thing to put in there that's kind of...
That's true,
You
right?
know,
so if you had something that was 12 gauge
Yeah.
or something, you put that Unistrut in there. And
I had a customer one time, years and years ago, that did a lot. He was a batch shop, so batch powder shop, and he did a lot of OEM parts,
Mhm.
and he invested in a data pack, and he actually kept one of each of his. He always required an extra part or a couple to put back. And he had a large rack right beside the oven. And every part was on the shelf labeled who the vendor was and what the part name was. And he didn't waste time. He didn't monitor his oven every now and then. Every rack of parts that went into they were all by rolling rack. But it was top to bottom, wall to wall, front to back parts. Okay, and whatever size they were packed as dense as they could get in, because that's where you make your money. You know, part density, line density is where the profit's at. Right. And they would leave one space open on every rack, and that would be like center back all the way to the door. And the last part to go on would be the one off of that rack that was cold, you know, from the shop floor, room temp, and they would rack that in the empty one. Everything else is coated except for that one, and they would put a probe on it and shut the door. So, not one, you know, it's, if you're running an operation and you have any kind of warranty tied to your parts at all, you're standing behind those parts.
That's right.
If I own that company, I want to be able to sleep at night knowing that all these parts that are going on, whether it's automobiles or boats or into service operations, into lighting, into whatever it is, I want to know that I'm not going to get that call from, you know, attorney so-and-so that he represents a client of ours that's about to be a no longer a client, and we are now going to enter into failure testing because all the paint's peeling off the parts while they're on, you know, 40,000 cars
That's
you
right.
know, or more.
And undercure is a big culprit.
It's
You know,
huge.
a lot of people are trying to increase their production times, get as much out as possible, and
Yep.
and undercure is a big culprit to
Can't
that.
cheat
And
the system.
the smart batch really makes a cool aspect of that because you don't have to run a data pack and then pull it out and hope everything was okay with that batch,
Yep.
right? Because you might have to go make some adjustments. With our system, you know live what's happening.
That's very cool.
Yep, and you can let it stay in there because you know it's not ready yet, and so it saves that one step. If you're changing a lot of parts, you know,
Yep.
it can be very beneficial.